the groups play musical chairs. They take each other's place around the ring. Being able to rotate and manipulate molecules is a necessary skill in organic chemistry. We have to know how to rotate and manipulate molecules. One way we can do that is with pancake flips and steering wheel rotations. I have a separate video on that below. In this video, we're going to look at 120 and 180 degree bond rotations. I have a molecule drawn here on the board. You should go ahead and build a model of this molecule to play along at home, and I have a model up here in the screen. If you don't have a model kit, I have a link to my favorite model kit below. When we do a bond rotation, we pick one of the bonds about which we are going to rotate. I am going to choose this bond as the bond that we are going to rotate. The bond connects two atoms together. The way we do the rotation is we choose to hold one side of that bond constant. I'm going to choose to hold the right side of this bond constant. And we rotate around the bond such that the three groups attached to the other atom of that bond end up rotating around each other in space. Where these three groups end up depends on whether we're doing a 120 or 180 degree bond rotation. We'll start with the 120 degree bond rotation. If we're holding one side of this bond constant and rotating the other side of the bond, we could rotate all the way around that bond in a 360 degree circle. So a 120 degree bond rotation would be a third of that circle. There are three groups attached to the other atom of that bond. So when we do a third of a circle rotation, what we're doing is we're playing musical chairs. One group will take the place of the other group, which will take place of the third group, and so on, all the way around the ring. The way we draw this is we leave all of the sticks in the same place in the molecule. This is the bond that we are rotating. We leave the in the plane bonds in the same place. We leave the wedge and the dash bonds in the same place. What changes in a 120 degree rotation is the groups play musical chairs. They take each other's place around the ring. So if I do a 120 degree rotation about this bond, the OH group will take the place of the CH3 group. The CH3 group will take the place of the hydrogen, and the hydrogen will take the place of the OH group. Let me show you in my model over here. If I select the bond that I want to rotate, this central bond of the molecule, I can rotate the OH group down to take the position of the CH3 group. Let's watch and see what happens. As I grab the OH group and I rotate it into position, down in the position where the CH3 group is, notice what happened to the CH3 group and the hydrogen. As I rotate the OH group down, the CH3 group moves back in the back plane on the dash, and the hydrogen moves up to the wedge in the front of the molecule. So the sticks stay in the same place. The only thing that changes is the position. The OH group rotates down, the CH3 group rotates back, and the hydrogen rotates onto the wedge. We can do this again with another 120 degree rotation. Again, the sticks will stay in the same place. The only thing that will change is the position, or the atoms that are on each of those sticks. If I grab the OH group in my model and I rotate it to be on the dash position and going into the plane of the board, notice what happens with the other groups. The CH3 group now moves onto the wedge and the hydrogen now moves into the plane. The only thing that changes is the position of the groups around the ring. The OH group is on the dash, the CH3 group is on the wedge, and the hydrogen is in the plane. By the way, this is a piece of software called Avogadro. It's a perfectly free piece of software. I'll put a link to the download down below if you want to download a copy yourself. We can do one final 120 degree rotation. 3 120 degree rotations would be 360 degrees, so that should bring us back to the original molecule. All the sticks will again stay in the same place. The wedge and dash will stay in the same place. The only thing that changes is the groups will play musical chairs around the molecule. If I grab the OH group, I can rotate it back into position on the wedge bond. That puts the CH3 group back in the plane and the hydrogen back on the dash on the backside of the molecule. This will complete the 360 degree rotation, bring us back to the original molecule. We should also be aware of how to do a 180 degree bond rotation. Again, we would need to pick a bond to rotate. Again, I'll pick this central bond. And again, I'm going to rotate around that bond, holding one side of that bond constant and rotating the other side of the bond. The 180 degree bond rotation is a hemisphere inversion. If the 120 degree rotation was musical chairs, 180 degree is hemisphere inversion. Let's take a look at the model and see exactly how that's going to play out. This one is easiest to see from the perspective of the group that is in the plane, so the CH3 group. I'm going to take that CH3 group and I'm going to rotate it 180 degrees. Right now it's in the plane pointed in the southern hemisphere, so I'm going to take that group and I'm going to do a 180 degree rotation. It's going to be in the plane still, but it's going to be up in the northern hemisphere. It will look something like this. The 180 degree rotation will invert the hemisphere of that in the plane group. So now the in the plane group is still in the plane, but it's now in the northern hemisphere. The rest of the molecule is still in the plane. Notice what happens to the OH and the hydrogen as well. They also flip hemispheres. They flip from the northern to southern hemisphere. But did you notice what happened to that OH group that used to be on the wedge? When we do the hemisphere inversion, if it used to be pointed towards you, when we do the hemisphere inversion, now it will be pointed away from you. That OH group will now be on the dash in the southern hemisphere, and the hydrogen will be on the wedge. So when we invert the hemisphere, we also invert the wedge dash notation when we do a 180 degree rotation. 180 degrees is half a circle, so if we do a second 180-degree rotation, that should bring us back to the original molecule. We'll take the same CH3 group and we'll rotate it back into the southern hemisphere. If I rotate that CH3 group back into the southern hemisphere, it's going to stay in the plane. That's what it means to be a 180-degree rotation. It will still be in the plane, but now it will be in the southern hemisphere. Notice again what happens to the OH and the hydrogen. The CH3 group is now back in the southern hemisphere in the plane. The rest of the molecule is still in the plane. And now the OH group, when it rotates hemisphere, will now be on the wedge in the northern hemisphere. And the hydrogen will now be on the dash in the northern hemisphere. We've completed the 360-degree rotation. The 120 and 180-degree rotations are certainly the easiest rotations. There are others, but these are the ones that you have to know in order to manipulate the molecules in organic chemistry.
Thanks for training with us today, Ninjas. Check out this other content to see if you can level up even further. As always, don't forget to like and subscribe.